Welcome to the Machine Learning at Home. Today I will speak about naive Bayes method of machine learning. The name is slightly funny, but it only reflects that naive Bayes method uses the strong or naive approach for independence of variables. So this is like a method will allow to use variables if they are independent from each other. Okay, and then we should load the library which has that method implemented, and since it doesn't come with R by default, many of you will need to install this package or library first. So you first type install packages. The name is E1071. Name comes from the number of seminar in Technical University of Vienna, where some R functions were developed. But I have this installed, so I will go to next step and simply load this package with library. And you will wait until it will install and then do the same. Now we should prepare our iris train and iris test subset from iris data, working with rows, and then to select every fifth row I will use a short logical expression 1 to 5 more than 4. That should work. And to make a testing subset we should negate the first one. That should work as well. Now we need to employ the main function, which name is naive Bayes. So we'll make an object immediately, NB for naive Bayes, and then function naive Bayes. So note the camel case, the first letter is lowercase, and intermediate letter B is uppercase. And then interface is the same formula as it was in all examples before. Species against all other 4 variables, and data will be iris train. So we'll make with train the model. And then we can type the name of model to see what is it. It's not very interesting output in that case. And simply give us some Bayesian parameters for the model. So it will show us the name of used classifier, discrete predictions. So it will also give us some call information. And since Bayesian approach always operate with probabilities, I can go deeper here today. So but always there are some prior probabilities, and there are also probabilities which will arise after some calculations. So prior and posterior. So with some of these probabilities are reflected in the model output. Now we use the model to predict our classes. PRED will create the object with that name, use the function predict as usual, and model name as usual, and new data iris test without species variable -5. And now we can compare our predicted species labels with actual species labels simply with table of our initial species labels for testing subset which were omitted, and new labels which are predicted. So as you see here, it's not so good as in many other cases, and I will explain why, but it's reliable. So for example, for Virginica only one item, only one observation was misclassified. The worst of all is versicolor, of which like 10 observations were misclassified. Anyway, why so difficult in a case of Bayesian naive Bayes method? One reason is that in most cases naive Bayes will use character discretization, so it will discretize characters in subcharacters to make them like categorical like. So this is one thing. And second thing, there is naive assumption, because naive assumptions tell us that it should be independence between characters. However, flower characters like sepal length, sepal width, petal length, petal width, they belong to one flower. They cannot be independent. That's by their nature. So this main assumption is violated. Hence, probably there is a relatively low quality of classification. However, if you have good assumption which works, so if your characters are really independent, and also if you have discrete characters, because naive Bayes can use any type of characters, and that way it is similar to CART methods, so you might achieve very good level of prediction with naive Bayes. Naive Bayes doesn't have any embedded methods of feature or variable importance calculation. However, you can always understand which of your samples was classified better or worse, because it will return probabilities of class belongings. You should obtain it with slightly different approach. So you should repeat the prediction step and add one new option. Type equal to row, and I will change name slightly, make it like Aris NB PRD2. And then, for example, as we did before, we can access rows from 60 to 70 simply by Aris NB PRED2, and then select rows from 60 to row 70. And I also recommend to round it, because it will be long numbers around, for example with 3 digits. And you will see that rows have different probabilities to be in some particular class. So you can see that row number 3 has especially bad situation, because like 40% for versicolor, whereas a 59, 60 almost percent to be virginica. So this is how to use naive Bayes. In many cases, people use it even if that main naive assumption is violated, and it performs pretty well. I would say that it performs pretty well even in our case. So only 11 out of 120 rows are misclassified. So this is naive Bayes, and we'll continue speak about machine learning on next lesson. Thank you.